It's their first taste of freedom. Researchers are releasing several Przewalski horses into the wild.
Have you ever imagined that just 11 Przewalski's horses could accomplish what billions of dollars and massive tree planting projects failed to achieve? A desert once thought beyond saving slowly came back to life, not through advanced technology, but by bringing back a forgotten species. How did these ancient wild horses revive an entire ecosystem? And what does their extraordinary journey reveal about nature's hidden power? Let's find out. Wild horses and desert revival. In December 1986, 11 Przewalski's horses, the last truly wild horse species on Earth, were released into the Jungar Basin Desert in China. This region was regarded as inhospitable due to extreme climate and ecological collapse. The basin was deemed a death sentence for the horses by ecologists. The land was barren, with temperatures ranging from -40 degrees Fahrenheit in winter to 104 degrees Fahrenheit in summer. There was a lack of water, and local ranchers believed nothing could grow there. This initiative was part of a 25-year conservation effort, starting from 4 wild horses brought into zoos for eventual rewilding. The horses had been bred in captivity in East Germany and the United States, spending generations eating hay and drinking from waterers. Their wild release seemed impossible to many observers. The Jungar Basin was once a thriving ecosystem shaped by wild horses for over 10,000 years until their local extinction in 1969. Following their disappearance, the soil hardened into biological concrete, becoming impermeable to water and seeds. Nitrogen levels in the soil plunged drastically, likened by scientists to lunar dust in terms of fertility. Satellite data from 1982 revealed the Gobi Desert expanding at 70 kilometers per decade, consuming farmlands and villages, disrupting transport infrastructure, and creating environmental disasters far beyond the basin. In 1983, Beijing endured a massive dust storm depositing 43,000 tons of soil, causing a 300% increase in respiratory illnesses. Previous efforts, including the Green Great Wall Forestation Project, failed due to water shortages. Water tables dropped up to 12 meters, and planted trees died from drought. Agricultural productivity dropped 34% by 1985. In 1985, researcher Yang Jianming proposed to the Chinese government a radical paradigm shift. He argued that instead of fighting the desert with trees and machines, they should bring back the wild horse that once maintained the ecosystem. Despite skepticism, Yang's plan was approved. The focus was on importing zoo-born Przewalski's horses from Western zoos, acclimatizing them in Jimsar, and then releasing them into the Kalamili Nature Reserve. The project aimed not just for survival of the horses, but also to restore the ecosystem via their natural behavior. Przewalski's horses have 66 chromosomes, unlike the 64 of domestic horses, and have never been domesticated. They retain traits from the Ice Age, offering a direct link to prehistoric wild horses depicted in cave paintings. By 1985, only about 900 individuals worldwide existed, all captive-born, descended from as few as 12 to 14 wild founders. The species faced a severe genetic bottleneck, surviving extinction in just 2 zoos after World War II. The 3-phase plan included import and acclimatization in a Jimsar breeding center, transition to semi-wild enclosures to relearn survival skills, and full release into 4,000 square kilometers of harsh terrain in Kalamili Nature Reserve. Among the first horses was a young stallion named Hong, who later became a key figure in the project's success. Yang's theory rested on 3 ecological contributions of the horses. First, brute force. Each horse strikes the soil with hoof pressure comparable to a jackhammer, breaking the hardened biological crust, allowing water to penetrate. Importantly, they selectively trample bare soil and dead vegetation, sparing fragile plants. Second, movement patterns. GPS tracking revealed horses travel about 15 kilometers daily in fractal patterns, creating a heterogeneous habitat of grazed and ungrazed patches that support diverse insects, birds, and mammals. Third, seed dispersal via manure. Horse dung contains viable seeds from over 20 plant species. Passage through the gut increases germination rates by up to 300%. 1 gram of dung averages 7.4 viable seedlings, surpassing dispersal rates of cattle and sheep. All horses had spent 3 to 4 generations in captivity, unaware of how to find water, avoid predators, or endure harsh climates. Researchers worried the culture of survival, learned behaviors passed from mother to foal, might be lost. The uncertainty of their ability to survive in the wild became the measure of Yang's vision versus folly. The initial months were brutal. There was a 100% botfly infestation causing digestive damage. Temperatures dropped to -42 degrees Fahrenheit, and snow buried forage beneath 3 feet of powder. Horses huddled against piercing winds, and some suffered frostbite and miscarriages. Interventions were forbidden unless the entire herd was at risk, as critics predicted the program's failure. Remarkably, horses began exhibiting survival behaviors never observed in captivity. Stallions broke ice to access water. Mares used collective body shields against storms. Horses learned to dig through deep snow to find grass and instinctively read wind and snow patterns for foraging. The conclusion was that the horses retained dormant wild instincts, awakening in the desert environment. In the first year, grass biomass in grazed areas increased by 43% due to compensatory growth. Soil moisture retention rose by 23%, attributed to horse hooves creating over 10,000 micro-depressions per hectare, capturing rainfall. In the second year, soil nitrogen increased by 37%, aided by horse manure reintroducing microbial communities. In the third year, botanists recorded 22 plant species re-emerging after 17 years. The recovery cascaded to 43 insect species, multiple bird species including larks and sandgrouse, small mammals such as gerbils and pikas, and apex predators including foxes, steppe eagles, and gray wolves. By the late 1990s, the herd had grown, enabling removal of enclosure fences. In August 2001, 27 horses were fully released into 4,000 square kilometers of wild desert with no human intervention. Initially reluctant, horses stayed close to the release area, but by day 8, a remarkable event occurred. Hong led his harem 30 kilometers to a previously unmapped spring-fed water source, demonstrating uncanny spatial knowledge. After a month, territories formed with natural stallion behaviors. Reproductive success soared with a natural foaling rate 87% higher than captive populations. Wild-born foals displayed sophisticated survival behaviors like recognizing 23 plant species by smell, freezing instantly at predator shadows, and growing thicker winter coats than their parents. Satellite imagery showed green vegetation patches expanding outward from horse territories. The previously declining water table, dropping 3 centimeters per year since 1970, stabilized in 2003 and then rose, reactivating a natural hydrological pump. In stark contrast to the failing Green Great Wall tree planting project, which spent $47 billion on 66 billion trees, the horses improved water retention and maintained grasslands that require 90% less water than forests. Each Przewalski's horse was estimated to deliver significant ecological services annually. Soil restoration was valued at $12,000 per horse per year, seed dispersal at $8,000, water retention at $15,000, carbon sequestration at $7,000, biodiversity support at $5,000. The total came to $47,000 per horse per year. By 2023, from the original 11 horses, the herd grew to 534 individuals, managing 26,700 hectares, generating roughly $25 million in ecological benefits annually. The desert was retreating at 47 hectares per year within horse territories. Mongolia introduced horses into Hustein National Park in 1992, growing to 490 individuals by 2023 with similar ecosystem recovery. Kazakhstan started the Golden Steppe project in 2024, releasing over 100 horses. Across Central Asia, nearly 1,000 Przewalski's horses roam wild, consistently demonstrating ecosystem engineering effects. China plans to expand Kalamali Reserve by 350 square kilometers and aims to have 2,500 wild horses by 2040. Models predict that this population could restore over 100,000 hectares of degraded land, sequester 43,000 tons of carbon annually, and support more than 300 endemic species. This would mark the first successful desert reversal achieved by biological engineering, not artificial planting or irrigation. The initial 11 horses were not just endangered animals, but a biological technology perfected by evolution over hundreds of thousands of years, capable of regenerating landscapes. Their success challenges conventional environmental remedial approaches that emphasize human-engineered solutions over ecological restoration via keystone species. Could many environmental disasters be addressed more effectively by returning original ecosystem engineers such as bison in the American prairie, wolves in European forests, or elephants in African savannas? Restoration requires reactivating these evolutionary solutions rather than relying solely on costly human interventions. The Przewalski's horse reintroduction represents a paradigm shift in ecological restoration. Rather than viewing desertification as a problem to be solved through technology alone, the project demonstrated the power of restoring natural ecological processes through keystone species. The horses did not simply survive, they actively reshaped the environment, creating conditions for other species to return and thrive. The concept of ecosystem engineers is central to this success. These are organisms that modify, maintain, or create habitats for other species. Through grazing, trampling, and waste deposition, the horses fundamentally altered the physical environment. Their hooves broke the biological crust that had formed in their absence. Their movement patterns created a mosaic of habitats supporting biodiversity. Their manure reintroduced seeds and nutrients absent for nearly 2 decades. The revival brought back associated species that had disappeared. Dung beetles returned in vast numbers, playing a crucial role in nutrient cycling. Birds dependent on insects and seeds found suitable habitats. Small mammals and predators gradually recolonized barren areas. The horses acted as a keystone species, crucial for maintaining the entire ecosystem's structure and function. This ecological restoration had tangible economic benefits. The conventional approach through tree planting cost billions and failed to halt the Gobi Desert's advance. The horses provided ecological services worth millions annually at a fraction of the cost. Their natural behaviors proved more effective at restoring soil fertility, retaining water, and sequestering carbon than any human-engineered solution. The project highlights the challenges of reintroducing species absent for extended periods. The horses had been captive bred for generations and lost many learned behaviors. That they retained instinctual knowledge, such as finding water and foraging in deep snow, suggests some behaviors are hardwired. Yet the transmission of cultural knowledge from mother to foal was also observed, indicating both nature and nurture play roles. The project also demonstrates the importance of patience and conservation. The 25-year timeline from import to self-sustaining population required sustained investment and political support. Short-term thinking would have doomed the effort. The horses needed time to adapt, learn, and reproduce before full release. The recovery was not immediate. It took years for the effects to become visible. Full restoration of soil fertility, water retention, and biodiversity required decades. Yet the results, when they came, were dramatic and measurable. Satellite imagery showed the desert retreating within horse territories while the Green Great Wall continued struggling. The Przewalski's horse story raises questions about the relationship between humans and nature. The initial elimination of the horses set in motion ecological collapse. Attempts to fight the desert through technology failed because they addressed symptoms rather than causes. Only when original ecological relationships were restored did lasting solutions emerge. The success should not be seen as a universal panacea. Each ecosystem is unique, and what works in the Jungar Basin may not work elsewhere. However, the underlying principle, restoring keystone species and ecosystem engineers, offers a powerful approach complementing traditional conservation methods. The most effective way to restore damaged ecosystems may be to allow natural processes to resume their work. The economic valuation of the horse's ecological services provides a compelling conservation argument. The $47,000 per horse per year figure suggests the benefits of protecting and restoring wild populations far outweigh the costs. This is particularly important where conservation struggles to compete with economic development. As other countries adopt similar projects, the Jungar Basin results will be closely studied. Mongolia has already shown similar ecosystem benefits. Kazakhstan's Golden Steppe project represents the latest expansion. If these projects succeed, they could provide models for conservation efforts in other regions facing similar challenges. The long-term goals for Kalamali Reserve, expanding the area and increasing the horse population to 2,500 by 2040, are ambitious. The projected benefits, restoring over 100,000 hectares and supporting over 300 endemic species, would represent a major conservation achievement. Yet achieving these goals requires continued investment, political will, and scientific monitoring. The story of the Przewalski's horses in the Jungar Basin is ultimately one of hope. It shows that ecological damage, even when severe and long-lasting, can be reversed through patience, science, and respect for natural processes. It demonstrates that species-driven solutions can be more effective than purely technological ones. The key to solving our most pressing environmental challenges may lie not in new inventions, but in restoring the ancient relationships that once sustained our planet.